Science. Are we living in a black hole? Mathematical quirks of our universe have led some cosmologists to wonder whether the cosmos was actually born in a black hole. Parallels in the physics of the universe and that of black holes have led some cosmologists to wonder if our universe could have been born in a black hole. Photograph by NASA Goddard. By Adam Mann. Gazing up at the stars at night, it's easy to imagine that space goes on forever. But cosmologists know that the universe actually has limits. First, their best models indicate that space and time had a beginning, a subatomic point called a singularity. This point of intense heat and density rapidly ballooned outward during the Big Bang. And second, the visible universe is circumscribed by what's known as an event horizon, a precipice beyond which nothing can be observed because the cosmos has expanded faster than the speed of light, leaving parts of it too far for even our best telescopes to see. These two elements, a singularity and an event horizon, are also important features of black holes. Such gravitational monsters lurk all over the cosmos, gobbling up gas, dust, and light. Like the universe, black holes are restricted by their own event horizons, a boundary past which nothing can be observed, that is believed to contain a singularity. Perhaps that's why a couple of recent scientific papers have suggested that our entire universe could exist inside of a black hole. While it rests somewhat outside the realm of ordinary cosmology, the mind-bending possibility of living in a black hole isn't just for contemplative college stoners up too late. It's certainly a reasonable idea, says Niyush Afshorty, an astrophysicist at the Perimeter Institute for Theoretical Physics in Waterloo, Canada. It's just making the details actually work. How a stranger's kindness during World War II helped give us the Big Bang Theory. A brief history of black hole universe theory. The mathematics underpinning our understanding of the universe are quite similar to those describing black holes. Both stem from Albert Einstein's theory of general relativity. That's the idea that objects in space create curves in the fabric of spacetime that govern their movements and explain how gravity works. Coincidentally, the radius of the observable universe happens to be the same as it would for a black hole with the mass of our cosmos. Over the years, that has led some researchers to raise the possibility that the universe is inside of a black hole. Two of the first to work out the particulars were theoretical physicist Raj Kumar Pathria and, concurrently, mathematician I.J. Good in the 1970s. Our cosmos is believed to have begun with a singularity, that point of infinite density that preceded the Big Bang. Black holes, by contrast, end in a singularity, an itty-bitty garbage disposal dot where everything is crushed beyond meaning. A black hole's event horizon, the spherical borderline around the singularity, is also its point of no return. While often seen as cosmic vacuum cleaners in pop culture, black holes are actually relatively placid objects. A spaceship can enter a stable orbit around one and then escape unless, that is, it slips past the event horizon, beyond which nothing can ever come back. Our universe's constant expansion drives a similar phenomenon. When we look out into the universe with telescopes, we see further objects moving away from us faster than closer ones. At large enough distances, the expansion happens quicker than the speed of light, shuffling stars and galaxies away so swiftly that they disappear beyond an edge, the cosmic horizon. It's almost like those stars and galaxies are disappearing down the maw of an inside-out black hole. Phew. Is your head hurting yet? Don't worry. The main point for scientists is that these superficial connections between black holes and the universe don't necessarily imply that one is the other. In order to take that leap, physicists would need to know what observable results such an idea might have. We have theories and they have consequences, says Alex Lupsaska, a physicist at Vanderbilt University in Nashville, Tennessee. If the implications of the theory are ruled out by an experiment, then we could say the assumptions are inconsistent or wrong. How to tell if your universe is in a black hole? So what would be the observable consequences if our universe was, in fact, inside of a black hole? For one, there would be a kind of natural direction or orientation to the cosmos, galaxies spinning in a favored direction or a subtle axis in the leftover heat from the Big Bang that fills the universe. You would expect some sort of gradient across our universe, says Afshorty. One direction would be towards the center of the black hole, another towards the outside of the black hole. Yet our best measurements show that, at the largest scales, the cosmos appears to be quite repetitive. Physicists refer to this as the cosmological principle. It states that the universe has no special direction, and it's the same pretty much everywhere. How such uniformity could arise from the birth of a black hole is a challenge for anyone claiming the cosmos is inside of one. Black holes are born from dying stars, a process that's messy, chaotic, and far from uniform. There is also the problem of the black hole's singularity. That infinitesimal point is a fated final moment for anyone or anything that falls inside a black hole, kind of the opposite of a rapidly expanding cosmos. You've heard of the Big Bang. But what is the Big Crunch? Getting a better handle on these issues would require physicists to figure out how to combine the two most successful theories of the 20th century, general relativity, which applies to the largest objects, and quantum mechanics, which governs the smallest. Since a singularity is a microscopic point with enormous mass, it cannot be handled by either theory alone and requires some kind of synthesis between the two. Despite many efforts, such a theory of quantum gravity has so far eluded scientists. For the same reason, we can't determine what precisely happens inside a black hole or before the Big Bang. Nevertheless, cosmologists agree that exploring some of these avenues is both a fascinating exercise and could potentially lead to new discoveries. Perhaps they might even find reason to reconsider their cosmic models and find that the universe really is inside a black hole.